we present VibEye, a vibration-mediated recognition system for handheld objects, which is to enrich interaction with tangible objects. In everyday life, we frequently manipulate various objects around us. To extend such experience to the realm of digital, it is essential to have a sensing method that recognizes a wide range of physical objects. VibEye identifies objects via their difference in material. We observed plausible grounds from object identification with vibration. In this research, we focused on how to distinguish objects that are made of different materials. With this approach, a user can interact with the objects that elicit rich haptic sensation. Like we shake an object to identify it, we imposed a frequency-modulated vibration to each object and observed responses from an accelerometer. The frequency modulation is analogous to changing the speed of shaking. We could observe distinct vibration patterns because the mechanical properties of an object, such as stiffness, damping, weight, and density, have significant influences on the propagation of vibration. We tested this approach on 16 standard objects that are identical in shape. The set consists of stacked, elastic, viscous, light, heavy, and soft objects. Since the vibration propagation dynamics are mostly non-linear, it is difficult to be solved directly. Instead, we designed a series of data processing pipeline to find distinctive features from the vibration. First, the pre-processing step is to handle unintended human errors like hand orientation and wrist movement. Detailed information is described in our paper. Next, we simplify the nonlinear propagation dynamics of the vibration by introducing short-time Fourier transform. This spectral analysis divides a signal into short chunks to specify both spectral and temporal information, and it is to linearly approximate the dynamics. The output of the spectral analysis is an image, named spectrogram. Eventually, we got 320 spectrograms from the 16 standard objects. As a simple and straightforward way to extract features from the spectrogram images, we conducted principal component analysis that extracts key features from a set of images in an unsupervised manner. We could observe clear patterns of PCA results across the 16 standard objects. The resulting patterns can be easily identified by a machine learning classifier. We trained our classification model using support vector machine, and the model accuracy was 94.4% on our test set. Further, we conducted a user study to verify the effectiveness of this one-person classifier. The average accuracy over 20 participants was 92.5%. Hence, it was worthwhile to see how our classification model recognizes unseen everyday object, other than the standard objects. VibEye allows handheld objects to function as computing interfaces for tangible interaction. To illustrate, we designed two applications that extend the affordance and the experience in the real world. The first application is a 3D modeling tool for material-rich 3D printing, and it uses 16 standard objects as passive haptic proxies. In this VR environment, a user holds a cube to recognize the pinched prop, and then applies pressure to the prop to draw their own 3D model. Our tangible props present a realistic haptic experience while modeling. The user can even erase existing blocks using the particular prop that elicits similar haptic sensation to erasers or a real eraser. In advance to the printing stage, it is possible to simulate behavior of the 3D model. The second application is a drawing tool in augmented reality. The application takes advantage of the affordance of objects. For example, a pen to draw and an eraser to delete. Also, strokes have the similar texture of handheld objects. Augmentation implies the existence of an entity. We believe that the progress in the quality and quantity of the entity would leverage tangible interaction in the mixed reality research. For more information, please see our paper.